Hello, and thank you for joining me. Today, I will be discussing how life cycle dominates the volatilome character of the dimorphic fungus Coccidioides species. Coccidioides or valley fever is a fungal infection endemic to the North and South American deserts. The causative agent of valley fever is comprised of two species, Coccidioides immitis and Possidacea. Cocci is a dimorphic fungus found in the soil and has the ability to switch between an environmental and host-specific life cycle. In the environment, Cocci presents as mycelia, whereas in a mammalian host, it forms spherules. Cocci is responsible for approximately 350,000 new infections each year, and in endemic and highly populated regions, such as here in Phoenix and Tucson and the San Joaquin Valley in California, up to 30% of community-acquired pneumonias may be caused by valley fever. Valley fever is difficult to diagnose by standard serological and histopathological methods, which leads to delay in diagnosis, inappropriate treatment with antibiotics, loss of productivity, and increased medical costs. There is a critical need for a sensitive and non-invasive diagnostic for detecting and identifying valley fever lung infections. For this study, we used 12 strains total of Cocci from 4 geographic regions. The cultures were grown in the same media and incubated to induce either spheruleal or mycelia life cycle. The volatile metabolomics of the samples were then analyzed using headspace solid phase microextraction with comprehensive two-dimensional gas chromatography coupled to time of flight mass spectrometry. We detected a total of 353 volatiles that were at least twofold more abundant in a Cocci culture compared to immediate control. The total number of volatiles produced by Cocci Possidacea at 291 was very similar to Cocci immitis at 309. Additionally, we saw the similarity between the volatilomes when looking at just the mycelia volatiles, with over 50% being shared between Cocci Possidacea and immitis. And again, with the spheruleal volatiles, with over 50% being shared between Possidacea and immitis. Next, we performed a principal component analysis using the 78 cultures and blanks as observations and the 353 Cocci isolates, Cocci volatiles as variables. You'll see here that Cocci Possidacea is in red, Cocci immitis is in blue, and the media is in gray. Additionally, mycelia samples are as squares and spheruleal samples are in circles. And we were able to identify that the Cocci volatilome is more dependent on growth phase, as we see separation by mycelia from spherules as opposed to by species, as there is no clear separation between immitis or Possidacea within the PCA. Next, we performed a hierarchical clustering analysis where we had these strains, the samples in rows being separated by Pearson's correlation, and the volatiles in columns being separated by Euclidean distance. You see here the strains and species, where again, Possidacea is red or warm colors, and Cocci immitis is blue or cool colors. The life form in maroon, we have spherules, and in tan, we have mycelia. And the HCA further supported what we were seeing with the PCA in that the volatilome of Cocci is more dependent on life cycle than it is on whether it is immitis or Possidacea. We attribute this to two main clusters. Cluster 1, which is far more present in spheruleal samples, and cluster 2, which are volatiles that are more present in mycelia samples compared to spheruleal samples. We have taken an in vitro guided approach to catalog the volatile compounds. We have shown that Coccidioides volatilome is growth phase dependent and that there are strong similarities between the species. We believe all of this will lead to the identification of a single suite of valley fever biomarkers that can be used for a breath test. Thank you. If you have any questions or would like to discuss this work further, please feel free to reach out and look for our forthcoming manuscript.